So if we don't have routers and we have switches where microsegmentation is, like Cisco likes to call it, where every host is in a switch port, we can see here that Bob is shouting or sending out a broadcast. This is transmitted out all ports on a switch by default. So we can see that this is one big broadcast domain, but this is the functions of a switch. We don't break up broadcast domains by default. We do break up collision domains. Now in this case here, we're going to create an internetwork by placing a router between these two LANs and by creating two different subnets or LANs. In this case here, when Bob is to send a broadcast, then it's sent only to the router and then discarded. Routers do not forward broadcasts by default. In this case here, Sally does not receive any of the data from Bob unless he specifically is sending data to her IP address. Now, it's important to remember for the objectives that you have different networking devices. Let's take a look at some of the devices that are new to the objectives. First, we have our wireless networks. We have an access point, which is just basically a hub, but instead of sending digital signals, we have digital signals here coming in, but coming out this way is analog signaling. All right, so this really is truly a modem or modulator to modulator. In this case here, it's going to run half duplex. Now we could run full duplex from here to here, but in this case here, the AP is going to connect our wireless hosts to the switch and just extend this collision domain. We also have our VoIP or our IP phones. We have our wireless LAN controllers. Now this is somewhat new for the CCNA, but a wireless LAN controller manages my wireless access points and frames, wireless frames, on the network. They control the wireless traffic. We also have our firewalls, and this is referred to today as our next generation firewall or next generation IPS. Firewalls are absolutely essential for today's networks. So what's new on here again? Our wireless LAN controller, which manages our wireless frames and our access points and provides the configuration and codes for access points. Our IP phones and our firewalls. Now, we can create a large switch network. We call this a flat network because by default it's one large broadcast domain. But in this example here, we have our router and then we have our layer 2 switching. Unless Cisco tells you differently, when you see a switch, everything is referred to as layer 2 switching. Now, in this example here, we'd have our different connections to our hosts, and these switches then connect up to, this would be considered our access layer. And this is considered our distribution layer. And in this case here, we could run a layer 3 switch to provide inter-VLAN routing, IVR, which provides routing between VLANs. So a VLAN is a breaking up or broadcast domains in a layer 2 switch network. So in this example here, I can have this one in different broadcast domains. This one would be in, say, VLAN 2. This one would be in 3, and this one would be in 2 and 3, and these guys could both be in 4. They're in different subnets, different broadcast domains, and we just refer to them as being in different VLANs or virtual LANs. For example, a host in VLAN 2 can't communicate to a host in VLAN 3. Now, we'll talk about this later, but just understand that for a host to talk from one VLAN to another, they have to go through some sort of layer 3 device, such as a layer 3 switch